Okay, so here is your lesson about function notation. So our previous lesson, we talked a little bit about functions and relations. So at this point, we should know that a function is, we could say, a relation where every input maps to only one output. So functions are often written as f of x. We read this right here, f of x. And this is probably review. I'm sure you went over something like this in your previous Algebra 2 class. But just so that we're all on the same page here, we will just review some function notation. So functions are often written as f of x instead of y equals 3x, or sorry, f of x equals 3x minus 5 instead of y equals 3x minus 5. This tells us that we're talking about a function named f of x and that it's dependent on x. It does not mean to multiply. So this is a really common mistake here, this multiplication, so multiplying f times x. So f of 2 here. So if you notice here, the x is being replaced by a 2. So everywhere where there is an x in my equation, I will replace that with a 2. So f of 2 is 3 times 2 plus 7. I can say that f of 2, 3 times 2 is 6 plus 7. So here, f of 2 is equal to 13. This means that when I input 2, I will output 13, or that 2, 13 is a point on my graph. So moving along, f of 5 is 3 times 5 plus 7. F of 5 is 15 plus 7, and here f of 5 is 22. F of 0 is going to be 3 times 0 plus 7. F of 0 is 0 plus 7, so f of 0 is equal to 7. Again, meaning that 0, 7 is the point on my graph. I also know that this happens to be my y-intercept. Over here, here's g of x, talking about this g of x function. G of 1 is 3 times 1 squared, so g of 1 is 3 times 1. So g of 1 will be 3. G of negative 5 is 3 times negative 5 squared. So g of negative 5 is 3, and negative 5 times negative 5 is 25. So g of negative 5 is 75. Moving on, working backwards, find the x value that makes each of the following true and use the functions above. So when there's an f here, it's talking about this f of x function, and when there's a g here, it's talking about this g of x function. So this is saying, I know that I have x, 16. So when y is 16, what is x? Or f of x is equal to 16. So I can go ahead and substitute in 16 for f of x. So 16 is equal to, and my f of x function is 3x plus 7. And so now I can go ahead and solve by subtracting 7 from both sides. And here I'll get that 9 is equal to 3x, so x is equal to 3. Or I can say that f of 3 is equal to 16. Moving on to an example with g. G of x is equal to 0. So 0 is equal to 3x squared. I can divide both sides by 3 and get that 0 is equal to x squared. So x is equal to 0. So here g of 0 is equal to 0. Moving on. Here we have an application problem. Swine flu is attacking Porkopolis, and the function below determines how many people have swine, where t is time in days and s is the number of people in thousands. So find s of 4. So s of 4 will give me 7 times 4 plus 2. So s of 4 is 28 plus 2. So s of 4 will be 30. What does s of 4 means? So here, this represents my time in days, and my s represents the number of people in thousands. So this is saying that at 4 days, we have 30,000 people that have been infected with the swine flu. Now it says find t when S of t is equal to 23. So let's set this up. 23 is equal to 7t plus 2. Again, let's think of this as time is something. 23 is the number of thousands of people. So when my y value or my output is 23, I'm solving for t here. So we'll subtract 2 from both sides. 21 is equal to 7t, so t is equal to 3. What does S of t equals 23 mean? This is talking about finding the number of days or the time when 23,000 people have been infected. Moving along, so translate the following statements into coordinate points and then plot them. So again, this is f of x is equal to y. So negative 1, 1 is a point that they'd like us to plot over here. 2, 7, f of 2 is equal to 7. 1, 2, 3, 4, 5, 6, 7 up over here. 1, negative 1, so over 1 and down 1 right here. And my input or my x value is 3 and my output or my y value is 0. So over 3 and up 0. Moving forward, we have this f of x is equal to y or y is equal to f of x. And this is known as a piecewise linear function because it's made up of straight line segments. Answer the following questions based on this graph, f of 1. So this is saying when x is 1, where is my function? So here is when x is 1. This is what this is looking for. So 1, 2, 3, 4. F of 1 is equal to 4. F of 5, 1, 2, 3, 4, 5 is down here at negative 2. F of negative 3, 1, 2, 3 is down here at 1, 2, 3, down here at negative 4. And f of 0 is asking for this y-intercept right here, which is at 2. So again, if you think of these as x and y coordinates, so whatever's sort of inside of this f piece here is your x value, and whatever this is equal to is your y value, it can be a little bit easier to interpret these values. Part B, solve each of the following for all values of the input x that make them true. So this is saying when y is 0, what is x? So I know that my y happens to be 0 at this line right here. This is my line, y is equal to 0. So this is really asking for this x point, this x value, and this x value. So my answer here is x is equal to negative 1, 1, 2, 3, 4, 5, 6, and 7. Okay, so notice how there's more than one value here. The next is asking when when f of x is equal to 2, or remember we can also read this as when y is equal to 2. So when y is equal to 2, that happens right here on this line, and coming back, that happens here at 0 when x is 0, so x is equal to 0, and it happens here when x is equal to 3. And so that is sort of an introductory lesson on function notation notes.